Welcome to JD's Prep. In this problem, we're told the following. During physical education class, Andrew recorded the exercise times in minutes and heart rates in beats per minute, or BPM, of 4 of his classmates. We want to know which one of the 4 tables that Andrew created best represents a linear model of exercise time and heart rate. To identify a linear model from a table like this, what we want to find is a table that has the output variable, in this case the beats per minute for the heart rate, that is increasing or decreasing at a constant rate throughout the table. So every change from 0 minutes to 1 minute, 1 minute to 2 minutes, 2 minutes to 3 minutes, and so on, all of those changes should be the same to have a linear model. If we start over here with student 1, from 0 minutes to 1 minute, we go from 60 beats per minute for their heart rate to 65 beats per minute, an increase of 5. From 1 minute to 2 minutes, their heart rate increases from 65 BPM to 70, which is another increase of 5. From 2 minutes to 3 minutes, we have another increase of 5. And from 3 minutes to 4 minutes, another increase of 5. Since student 1's heart rate was increasing at a constant rate throughout those 4 minutes, this table represents a linear model of exercise time versus heart rate. If we do the same thing for the other 3 students, we're going to see that there are some differences in the change in heart rate from 1 minute to the next. For instance, in student 2, going from 0 to 1, we have a difference of 8 beats per minute. But then from 1 minute to 2 minutes, we have an increase here of 13 beats per minute. Already a difference. It's not a constant rate throughout the entire 4 minutes. If we finish filling those in, we have an increase of 5 for the next minute and 2 for the last minute. Definitely not going to be a linear model, because there's a change in the rate of change for their heart rate. Similarly, for student 3, we have an increase of 7 here, then an increase of 5, then another increase of 5, and an increase of 4 to finish it off. A little bit better than student 2's, it's closer to being a linear model, but there's still a little bit of change. So it's also not going to represent a linear model. Lastly, for student 4, going from 62 to 65, we have an increase of 3 BPM, then an increase of 1 BPM, then an increase of 7, and an increase of 2. So none of these other 3, student 2, student 3, or student 4, none of them have a constant rate of change for the heart rate throughout the entire 4 minutes. The rate of change is changing from 1 minute to another. So whenever you're looking for a linear model, make sure that the differences between the output values, in this case, again, the heart rate, from one input to another, are constant throughout the entire table, and you'll find your linear model.